All right, so yesterday we looked at area. Today we're going to look at compound area, okay? So we're going to start with this shape right here. We know that that is a trapezoid, right? And in a lot of cases we can find the area of a trapezoid. But is there a way to divide this into two shapes which might be even easier? What two shapes could we divide it into? Rectangle and a triangle. So we could have a rectangle and a triangle. And we're going to write the names of them. Rectangle and a triangle. Okay? How does separating a regular composite figure into various geometric figures help you calculate the perimeter and area of the irregular figure? It makes it easier, right? In some cases, this might be easier to do. Okay? Easier to find the area. So in this case, we could have used a trapezoid, but like for the warm-up, there was no formula for that funky shape. So we had to break it apart to two things. So sometimes it's impossible. Okay, we're going to look at number 3. So number 3 is a trapezoid, but I do not know the height up here. Well, I do because I have this right here. But we're going to figure out in two separate ways. We're going to figure out the perimeter, and we're going to figure out the area. Which do you guys want to do first? Perimeter? We can do perimeter. Okay, so for perimeter, I know this is 13.4 up here, so I can walk all the way around except this slanted part, correct? So that slanted part, I need to be able to figure it out. So I'm just going to divide my paper in half right here and call this side perimeter, this side area. And I need to figure out the slanted area. Well, I know this part right here is 12.5. So I am going to use what to figure out that slanted part of that right triangle? Pythagorean theorem. So I'm going to go 12.5 squared plus 10 squared equals, I'm just going to call it c squared. Okay. And then I'm going to go through and solve that. And what do I get, guys? You do it. Oh, slow down. So I don't need you to put 12.5 squared plus 10 squared in your calculator and tell me each of those parts. I just want the whole answer. What does C give me? 16. Okay, so now I'm going to add up the outside. I'm going to go 16. Yep, I'm going to wait because I've already been told I'm going too fast. We okay? So I'm going to go 16 plus 13.4 plus 12.5 plus 13.4 plus 10, and that's going to give me 65.4 meters. Yeah. Okay, so this is if I'm walking around the outside. So I put my 16 there, right? So I'm going 16 plus 13.4 plus 12.5 plus 13.4 plus 10. Right? It's just as if you're walking around the outside, though. Yes. 65.4 meters. But you have to add it because it's as if you're walking around the outside. I can't just count this 13.4 because here's my little walking. I'm walking 16. I walk 13.4. I walk 12.5. I can't skip 13.4. I have to still walk 13.4 and walk 10. Does that make sense? Okay. Area, I think, in this case, is actually easier. Because I'm going to find the area of the triangle and add it to the area of the rectangle. So I'm going to take 13.5 times 12.5. That's my rectangle. And then I'm going to add it to 10 times 12.5 times 1/2. Everybody okay with that? Yes. Is that better? Okay. So that gives me 230 meters squared.
You said 2.5?
230. Okay, we're going to go to number 4. We're going to calculate the perimeter and area of the shaded region in the drawing of the 2 circles at the right, and we're going to round to the nearest tenth. So I just want the shaded region, which means I don't want those circles. Okay? We're going to find the perimeter first because I think it's pretty easy, and then the area is a little bit more complicated, so we'll do that second. Okay, so here's my perimeter on this side, here's my area on this side. I want my perimeter of this rectangle. What do you think I'm going to do? 21 centimeters, then what? Good. And then what's this top part going to be if I'm walking around it? That's also 21, right? Excuse me. And then I still have to walk down, so that's also 10.5. So that gives me a total of 63 centimeters. And with perimeter, we don't have the squared, because it's just a straight line that I'm walking. All right, so let's kind of figure this out. I want the area of just that shaded region. I have no formula that gives me whatever that shape is, right? So how am I going to do that? How am I going to figure out what that is? Can I figure out the area of the whole rectangle? That's not hard, right? But then how am I going to get rid of those circles? Instead, that's a good answer, but what if it's not allowed?
Find the area of the circle.
Find the area of the circles, and what do we do with that area of the circles once we find it? Subtract it. So I'm going to write a little note to myself so I remember what I'm doing. I'm going to find area, rectangle, and then I'm going to subtract 2 circles. I like to write a little note to myself so I remember what I'm doing, how I want to set up the problem. Okay, how am I going to find the area of the rectangle? Just multiply. 10.5 times 21. Okay, I'm going to subtract. How many circles do I have again? So I'm going to put a 2 here, and then I'm going to put the area, how to find the area of a circle. Anybody remember how to find the area of a circle, what that formula is? Pi r squared. Okay, what does r stand for? Radius. Okay, so I know from here to here is 10.5. Is that the radius? What is the radius? Anybody remember the definition of a radius? From the middle to the edge. So if the whole thing is 10.5, what's from here to here going to be? Half. So 5.25, good. So we're going to say pi 5.25 squared. You guys, you had to find the area of a rectangle and the area of a circle. Okay, so let me just tell you right now, you are going to use this stuff in real life. You do have to calculate area a lot in life. When you're talking about new carpet, let me tell you, they were going to charge me. I had them carpet my basement, right? And they're like, it costs this much. And I was like, wait a minute, how much does it cost, like, square foot? And they told me. And I was like, how many square feet do you think? They measured incorrectly. They were going to charge me like an extra $100. $100 is $100. I went and measured it, proved it to them, and then they charged me less money. I was like, do not bring $100 more worth of carpet to my house that you're not going to use because you guys can't measure things. This is important, finding area. But it happens all the time. So in this case, this right here, what if it was 1,000?
Oh well.
It could have been. If I wanted to like tile my floor.
Or you can do it yourself.
So then you definitely have to find the area if you're doing it yourself. Okay, let's say right here, let's say this is your backyard and you need to put new grass down. And these two circles are ponds in your backyard.
Or I could just move it to a.
Then if you're using grass seeds, you still need to know the area to know how much grass seed to buy. I know.
Hard job.
Whatever you don't need to sell it.
A lot of places won't buy stuff back.
Don't gotta be places, gotta be people.
This stuff that we're doing right now is actual stuff that you need to know in real life. It really is. A lot of the stuff, like, no, you don't usually have to transform dilate a triangle and then rotate it 90 degrees. That's something you don't often have to do, unless you're going to be an engineer or use CAD or something like that. You'll have to do this. Everybody in here, this will be relevant at some point in your life.
Well,
Finding it.
people would remember, that's the thing.
I'll give you $100.
I'll be waiting. Let me know after you buy your first house, Grace. I'll wait here. Okay. All right, so we're going to do number 5. Shh. Find the area of the shaded region in the drawing of a square in the right. Round to the nearest tenth and show all your work. Okay.
Wait, before the circle, do you multiply it by pi first and I go square?
Oh, and the answer is 47.3, and it does not matter.
It doesn't matter.
It's 47.3 centimeters squared. And I would put it in your calculator all at once. Less work. I would not go 10.5 times 21, find the answer, and then the other part. I would put it all in at once. And I would like you guys to actually practice that now, because when we do our project, it's going to make so much more sense to just write out a nice long formula and then put it all in at once into your calculator. Okay, we're going to find the area of the shaded region. So this is a square. So first thing I'm going to do is go 15 times 15. That's the whole square. How do I get rid of the little square in the middle? Subtract 5 by 5. Okay, and we end up with 200 millimeters squared. Okay, so I think a good suggestion is we're going to turn this over and you're going to pick either problem 1, problem 2, or problem 3 for me to do so that you guys still have some time to work on your other stuff instead of me doing the whole thing. So problem 1, you're painting a garage, but you're not painting the door, so we have to figure out the area. Number 2, we're carpeting our living room and hallway, so we have to figure out the area. Number 3, we're putting a fence around this place and seeding it with grass. So you want to do 1, 2, or 3? Who wants 1? Who wants 2? Who wants 3?
Yeah.
Okay, so 3 it is. All right.
Well, hold on, wait a minute. That was it. Ain't nobody even raised that.
I know. There was 1 person for 1 person for 2, but 3 people for 3. So 3-1. Sorry, if you chose not to vote, you didn't get a choice. So like, just like real life, if you don't vote, you don't get a say. Okay.
Yeah, we need to read some.
The school's athletic director wants to seed the field and replace the fence. The field is shown at the right. How many meters of fencing will he need to purchase? If we're doing fencing, are we doing area or perimeter? Perimeter. Okay. So, you guys agree from here to here is 50, right? We agree from here to here is 50 up at the top. Oop, not. Okay. So, down here, we've got to find these curved sections. How are we going to find the curved
Well, we
sections?
know this one.
So we do know that part is 30, but the fence has to go around this curved area. So we're going to find what, Braylon? We're going to do diameter times pi, which is the what of a circle? Circumference or perimeter of a circle. So diameter times pi, or 2 pi r. Diameter times pi. And we don't want to cut it in half, even though this is a half circle, because we have the same half circle on the other side. Okay? So to find the perimeter, we're going to go 50 plus 50 plus 30 times pi. And what do we get, guys? Anybody? 194.25 meters. Okay. How many square meters will be needed to seed the area? So if we're doing seeding with grass, are we finding, what are we using? What do we need to find? The what of this? The area. Okay. Well, I know this rectangle is going to be 50 times 30, correct? How do I find the circle, the half circle parts? What's the formula again for area of a circle? Pi r squared. So we're going to go pi. What's r? Because the diameter is 30, so r would be
60,
15, half. It's half. Okay. So we put that in there and we get what, guys? What's my answer? Should be 3,206.88 meters squared.
So what would it be, 0.9?
You could round to 0.9. Yeah, that would be fine. Okay, and the most important part, if you're actually doing this in real life, is figuring out how much it costs, right? So if seeding costs $1.45 per square feet and fencing costs $23.50 per meter, how much will it cost to seed and replace the fence? How am I going to use that information to figure out how much it costs?
When do we do?
So if it costs $1.45 per square meters and we know we have 3,206.88 square meters, what do we do?
I got 2,000.
Yeah, we just times it.
Yeah, I got 2,206.
Let me see your calculator.
Okay. I thought it was okay.
No, I might have done something wrong too, so that's why we're checking. Okay, so we did 50 times 30 plus pi 15 squared. Oh, you're right. That's why you always double check, right? We would have gotten, you guys, we would have gotten over 1,000 more square areas of seed than we needed. So that's why we got to double check those. Okay, so we're going to go 206.86 times 1.45. And then we're going to add it to the length of fencing we need, 194.25. And we're going to times it by 23.50, right? Are we okay with that? Right here?
Yeah.
That's 25, sorry. My handwriting's never going to get better. Sorry, guys.
It improves on its own.
Okay. So, put this in your calculator. I don't have the answer. I didn't solve it yet. So you guys tell me. How much is it going to cost us? Somebody solving this for me? 7,764.82. So it's going to cost $7,764.82.
That's not that bad.
I mean, it's for a school athletics director, right? This isn't in your house. Okay? So this is like, you know, it's in there. All right. I am not going to assign this classwork to be done in class. I am going to assign it as homework instead because I don't think you guys have enough time to finish it in class. But I am going to do a problem or two to get you guys started. Okay, so this thing is, why did the king's birthday celebration last so long? And you're going to do each exercise and find the answer in the code key, notice the letter under it, and write this letter in the box containing the exercise number. So we're going to find the probability if you spin the spinner once and land on red. So how many possibilities do I have here? 5. And how many, like if I spun it, I only have 1 chance to land on red, right? So that's like 1 out of 5, okay? So I look up here, 1 out of 5 says T. So then I go down here and wherever I see a 1, I put a T. Does this make sense how you do this? Okay, so I got 1 out of 5. We're okay with that? There's 5 possibilities, only 1 of them's red, so 1 out of 5. Then I look up here, 1/5 is T. So then I go down here and wherever I see a 1, I put a letter T. And it's going to answer the question, why did the king's birthday celebration last so long? I kind of like these. I know they're kind of silly, but I like them because you know right away if you did something wrong, if the answer doesn't make sense, right at the bottom. If it's like not a word, then you did it wrong. All right, let's turn it over and make sure we understand how to do all of them on the back. All right, this says, when the boy tire maker marries the girl tire maker, what did he say? It's kind of the same, similar thing that we're doing here. A says, suppose you roll a regular 6-sided faced die. How many equally likely outcomes are there? 6. Okay? If you roll the die once, what's the probability of rolling a 3? 1 out of 6. Okay, just wanted to get us going. So for wherever we see 6, we're going to put an A. So I'm going to the bottom. Here's an A for 6. And wherever I see 1/6, I put an E. So I put an E. We okay? So you're going to try these, and then your homework is just breaking up these shapes into shapes that you can actually find the area for using formulas. So like this one, we can break it right here, right? And it has a triangle and a rectangle. This rectangle is going to be 17 by 10. And this triangle, we know 17 minus 13. So 13, 14, 15, 16, 17 is 4. And then you're going to have to use Pythagorean theorem to find that unknown length. So that one is a little bit long. Most of them are not. The back, there is some shaded region. I am going to put this back up here. I know it's a lot of homework. I do want you to try to get as much of it done as possible. Okay? Of the area and the probability. I'm giving you the rest of class to work on it. I know that's not a lot of time. I'm making each of these worth 10 points, so if you just finish one for tomorrow, you get 10 points. If you finish both, you get 20, okay?